Hi, in this video, I'm going to show you my solution to the inscribed circle classic problem. In this problem, we have a square, we have an equilateral triangle with one of the vertices at a corner of the square, we have an inscribed circle with radius 1, and we need to find the area of the three triangles, the shaded triangles. So the first thing is I do this diagonal. Then I dropped the perpendicular to this side of the triangle. A tangent is perpendicular to the radius drawn to the point of tangency. So we have right angles here. And since this is an equilateral triangle, it's 60, 60, 60. If I draw in the point from the center of the circle to the vertex of the triangle, that forms a 30, 60, 90 triangle. So this problem is lovely because it has 30, 60, 90 triangles. It also has a 45, 45, 90 triangle. So if we first of all look at the 30, 60, 90 triangle, the short leg is 1, the long leg is √3, and the hypotenuse is 2. Now, if we move down here, we have the big 45, 45, 90, and we also can divide it into two 45, 45, 90 triangles. If we look at this smaller 45, 45, 90 triangle, the two legs are √3, and this distance down here is the square root of 2 times the leg. √2 times √3 is √6. So I need to find the side of the square. I'm going to call that D. So the square is D by D. Now I'm going to do the Pythagorean theorem on right triangle ACB. Right triangle ACB is not 30, 60, 90, but it is a right triangle. I can use the Pythagorean theorem. This leg is D minus √6. This leg is D. And the hypotenuse is 2 √3. So here's the Pythagorean theorem. To square this, I square the first term, I get D squared. I double the product and get negative 2 √6D. Then I square the second term and get 6. Squaring this up, I get 12. Adding like terms and subtracting 6 from both sides gives me this equation. Dividing by 2 gives me this equation. It's a quadratic equation. If I apply the quadratic formula, I get D to be √6 plus 3 √2 all over 2. A little bit messy at this point. I am using the positive on the plus or minus choice because D is a distance and it cannot be negative. So now I calculate the area of the square by squaring D. If I do that, I've got some more squaring of binomials and so on, and I get 6 plus 3 √3. The area of the white triangle, which I want to subtract from the area of the square, is 1/2 base times height. I'm using a base here of 2 √3 and a height of 3. So I get the area of the triangle is 3 √3. If I want to find the area of the shaded, I take the area of the square minus the area of the triangle, and I get a cold 6. Very nice. Have a great day.